This is the 4.9b worksheet. Number one, they want you to graph the system of equations. One is a parabola here. You can see by the x squared, and this one is just a regular straight line. Let's start by just graphing the line. It has a y-intercept of 1, so it's going to go through. It's going to go through right over here, and it has a slope of -2. So you go down to right 1, down to right 1, or up to left 1. Let's connect those with a straight line. Let's make that a little straighter here. Alright. Let's put some arrows on those. Now we want to graph this parabola. Let's find the vertex. So the opposite of b over 2a is going to be -3/4. Let's plug that back in. So 2 times 9/16 plus 9/4 plus 1. 2 goes into 16 8 times, so we have 9/8. Let's make all of these eighths. So 18/8 and 8/8. Sorry, this is supposed to be a negative here. So this is -8/8. Let me just erase this here. Okay, so minus and a minus. So 9 minus 18 is -9. -9 plus 8 is -1. So -1/8. So that's the vertex. So -3/4, which is -0.75, and -1/8. So it's going to be right around here. Let's move that a little bit to the right. Okay. Now we know that the y-intercept is 1, so we could have a point here, and we also, because it's -3/4, we're going to have -1.5, 1 as a point. Let's also plot another point here. Let's put 1 in here. So we would have 2 plus 3 plus 1 is 6. So 1, 6 is going to be on it. And this is 1 3/4. So 1 3/4 again will be right over here. So let's connect these points. And it looks like the two connecting points are going to be right here and right there. So it looks like my answers are going to be -2.56 and 0, 1. And those are our answers. You can check those on a graphing calculator and it comes out right. Alright, solve by substitution. We're going to take this and substitute it in for y. So we're going to have x plus 4 equals -x squared plus 2x plus 10. Let's move everything to the left. So x squared minus x minus 6 equals 0. Let's factor that. So we have x, 3 and a 2. The larger number, this is a 6 here. Larger number is a 3, smaller number is a 2. Sorry, the larger number is negative, the smaller number is positive. So our x values are going to be 3 and -2. So in order to get our y coordinates. We have to plug these back in. So 3 plus 4 is 7, and negative 2 plus 4 is 2. And these are our 2 points of intersection. Solve the system. So let's set this equal to this. So 2x squared minus 2x minus 3 equals negative x squared minus x minus 3. So let's move everything over here. So add the x squared, we get 3x squared. Add an x, we get minus x. Add a 3, and they cancel. So we want to factor this. We have a greatest common factor, which is an x. So we factor that out, and we get this. So that means x equals 0 is 1, and 3x minus 1 equals 0. So if we add the 1 and divide by the 3, we get x is 1/3. So what we're going to do is we put 0 into any one of these. We'll get negative 3, because it cancels this and this term if x is 0, and then 1/3. So let's plug that into the bottom one. So 1/3 squared is 1/9. 2 times a 9th is 2/9. This is 2/3, which is the same as 6/9. And then 3 is 27/9. So 2 minus 6 is negative 4. Negative 4 minus 27 is negative 31. So we have negative 31/9. And these are our 2 answers. So we have another solve by graphing. We're going to want to get the vertex for both of these. So the top one, the opposite of b over 2a, is going to be 3 over 2. So let's plug that back in. So 3 over 2 squared minus 3 times 3 over 2. This is going to be 9/4 minus 9/2. That's going to be negative 9/4. So that's your first vertex up here. 3/2, comma, negative 9/4. So if we plot that, that's 1.5 comma negative 2 1/4. So right around there. We know that this one over here has a y-intercept of 0. So let's plot that. And we'll plot the symmetry point at 3 over here. We can also plot a couple other points. Let's make 4 up. Let's put 4 in just to see how high we go. 4 squared is 16. Minus 3 times 4 is 12. So 16 minus 12 is 4. So 4 is here. And we'll have 4 there. Remember, it's not equal to, so it's going to be a dotted parabola. So that's our first one. The second one here is going to be the opposite of b over 2a, which is 3/4. Let's plug 3/4 in. So this is 9/16 times 2 is 9/8. This is 9/4, which is the same as 18/8. So negative 9/8. So the vertex for the second one is 3/4 comma negative 9/8. So 3/4 is right here, negative 1.18 or 1.125. It's right here. I'll put that in this color there. This also has a y-intercept of 0. So I could plug that point here and then here. The reason why it's at 1.5 is because the vertex is at 0.75. So this is 0.75 to the left. 0.75 to the right of 0.75 is 1.5. We're going to need a couple more points though. Let's plug in 3 over here. If I plug in 3, 3 squared is 9. 9 times 2 is 18. 3 times 3 is 9. So 3, 9 is a point on the graph, which is 1.5 units to the right of this one. So 1.5 units to the left would be right around there. So if I plot that one, or if I draw that out, let's just get a, I'm going to have this isn't the best graph in the world. The solution area is because this is less than, that's greater. It's going to be greater than the black, less than the blue. It's actually going to be everything in here, and there's a small sliver in between here that if I would have drawn it out perfectly, you would see it. So what I'm going to do is I'm going to use this graphing calculator, enter them in, these in here, and show you what it would look like. So it's greater than. So we're going to put this to the arrow pointing up. So it's going to be x squared minus 3x. Then down here it's less than, so I'm going to go over, hit it a few times, and it's going to point down. It's less than, so 2x squared minus 3x. Then I'm going to graph those two. So you kind of see that this area here is the main area. We can zoom in over here. Let's do that real quick, just to see if there's anything in between. Start there, go down, and to the right. Let's see what that shows us. Yeah, see, there's a really small sliver right here that I tried to show here, and all of this, which is all of this here. Alright, number 5. So we want to solve the system, so what we're going to do is we're going to set them equal to one another. So 3x plus 8 equals negative 3/4 x squared minus 4x. So what I'm going to do is I'm going to multiply both sides by 4 to get rid of the denominator. So we're going to have 12x plus 32 equals negative 3x squared minus 16x. We can move everything to the left, so we're going to have 3x squared plus 28x plus 32 equals 0. If we use the box method here, we'll have 3x squared here, 32 there. Our AC is 96. But we know that they're going to be the same sign, both of which is positive. So we're going to have a sum of 28. So if you do all the combinations of 96, eventually you're going to get to 4 times 24. And that's actually the combination that we want. So if I factor out, I have an 8, an x, a 3x, and a 4. So we're going to have 3x plus 4 times x plus 8 equals 0. That's going to give me two answers. The first answer is negative 4/3, and this answer is negative 8. So what we can do is we can plug these in for x here and solve for y. So if I plug in negative 4/3 for x, I'm going to have 3 times negative 4/3 plus 8. The 3's cancel, so negative 4 plus 8 is 4. And then when I plug in negative 8, I'm going to have 3 times negative 8, which is negative 24. Negative 24 plus 8 is negative 16. So these are my 2 points of intersection. Number 6, another graph. This one appears real easy. It's just a regular parabola. So let's plot a bunch of points for that. 1, 1, negative 1, 1, 2, 4, negative 2, 4, 3, 9, negative 3, 9. And let's just hit this with a dotted parabola. And this other one here is a parabola that is moved up 1 and flipped over the x-axis. So this is actually going to be an easy one to draw. Because if it's moved up 1, this point is going to go here, and everything else is going to fall down from that. So if I were to, for example, put 1 in here, I would get 0. That means negative 1, 0 is a point. If I plug in 2, 2 squared is 4, negative 4 plus 1 is negative 3. So 2, negative 3, and negative 2, negative 3. Negative 2, negative 3 here. 3 squared is 9, negative 9 plus 1 is negative 8. So we're going to have another parabola. Goes up there, and then down. So it's everything greater or higher than the black, less than the purple. So what we're going to have is this area right here. Do that with this area right here. Alright, simplify this. What we're going to do is FOIL. 1 times 3 is 3. 1 times 2i is 2i. 5i times 3 is 15i. And 5i times 2i is 10i squared, which is negative 10. 3 minus 10 is negative 7. 2i and 15i is 17i. Alright, rewrite in vertex form. So the first step is to move the constant over. So that's what I'm going to do. So y minus 6 equals negative x squared plus 4x. I want to factor out the lead coefficient, which is a negative. So I have this, and I'm going to leave a space. So half of that squared is 4. But what I'm really doing is I'm subtracting 4, because a negative times a 4 is negative 4. So I have to do that on this side. So y minus 10 equals negative parentheses x minus 2 squared. And that's in vertex form. Number 9, the vertex here is going to be 2, 5. The axis of symmetry is x equals 2. Don't forget the x equals. It opens down, so it's going to have a max value of 5. The domain is all reals. The range is the set of all y's such that y, since it opens down, is less than or equal to 5. And number 10. Engelbert says to you, I must have made an error when graphing this parabola because its axis of symmetry is the y-axis. Write out what your response might be to him. So what he's telling you, what he's freaking out about, is when he's graphing some parabola, he's finding that the axis of symmetry, let's say that the vertex is here, the axis of symmetry is the y-axis. This isn't the best picture in the world, but that's alright. So he's saying this parabola's axis of symmetry is this axis, the y-axis. He says that because of that fact, he must have made an error. So basically what he's saying is, he's saying that you cannot have a parabola that has a vertex that lies on the y-axis. Because if a vertex lies on the y-axis, then the y-axis is the axis of symmetry. Because remember what the axis of symmetry is. It's the vertical line, the imaginary vertical line that goes through the vertex. So if the vertex is on the axis of symmetry, then the y-axis is the axis of symmetry. So the question is it possible for a parabola to have a vertex on the axis of on the y-axis? The answer is absolutely. I mean, if you take the most common parabola, y equals x squared, the vertex is at the origin. Therefore, the axis of symmetry is the y-axis. There's nothing wrong with that. You can move this parabola up or down. You could have, for example, f of x equals x squared plus 10, which is this moved up 10 units. You could have f of x equals x squared minus 3. You can move this down. You could even flip. You can move it up and flip it, just like we graphed, I don't remember which one it was, I think number 6. So all of these, if b equals 0, if you don't see an x term, just an x squared and a constant, all of those lie on the x-axis. On the y-axis. So it's definitely possible. He didn't make an error.